Hey everybody, so I haven't made a video in a while with all our technical problems, but I think I'm back and running, so hopefully this will work well. I'm going to go over here and see if I can find a purple pen real fast. Should have done that already. This is a video to review in case you have any questions about what you did in class. I've already posted the answer key on Canvas, but this is just to help talk you through if you're not exactly sure what the answer should be. So, looking at our first problem, first of all, our directions tell us for each representation of a function, decide whether the function is linear, exponential, or neither. And give at least 2 reasons for your answer. Well, looking at number 1, I hope your brain is screaming linear because it's a line. That's one reason right there. The graph is a line. Graph is a line. And it has a constant slope. It's going through 2 points, and it looks like we could find the slope between those 2 points. So it has slope through 2 points. And you could even find that slope. This slope is actually, it has a negative slope because our slope is equal to our rise over our run, or our change in y over our change in x. And sometimes we even write y2 minus y1 over x2 minus x1. But if we find that rise, looks like we're going down 0.5. So down 0.5, and to the right from negative 3/2 to 0. So negative 3/2, if you really wanted to put that, this is right, this is -1, -1.5. So since I used a decimal, I'm going to use negative 1.5. But I know many of, not negative though, it would be positive because we're going to the right. And so putting this in, we actually would have to multiply by 2 to get something that looks normal, like -1/3. And then if we went down 1 and over 1.5 again, we would still be on that line. We would still be on our line. So, number 2. Looking at my table, Miss Baker, we love tables. We're going +1, +1, +1, +1. But 64 minus 32 is going to give me 32. 32 minus 32 is going to give me 0. So subtracting is not my pattern. And if we're going down, another pattern is to maybe see what we're dividing by. 64 divided by 2 is going to give me 32. 32 divided by 2 is going to give me 16. 16 divided by 2 is going to give me 8. Maybe it's easier for you to work with the smaller numbers before you get to 64 divided by 32, but hopefully you see that we are dividing by 2. So dividing is the same as multiplying by 1/2. And anytime we're multiplying, we are going to have a function that is exponential. So our table shows us that this is exponential. We are multiplying to get the next number. And if you were to sketch a graph here, guys, this would have to be 10, 20, 30, 40, 50, 60. And then if we did 1, 2, 3, 4, 5, 164 is going to be way up here. 2, 10, 20, 32 is going to be here. 316, we're all the way down here. 4, 8, and then 5, 4. See how we have our curve. This is not linear. This is our curve. So this would be exponential decay. Exponential decay, because we're dividing. We're multiplying by a number that is less than 1. Well, as usual, I'm talking too much, so I'm going to have to move a little faster. Y equals 4x is going to give us a linear function because it's in y equals y. Y equals mx plus b. It's in a linear model, mx plus b, linear equation. We have our x multiplied by our rate of 4, so we have a slope of 4. X is not an exponent. Exponential only happens when our x is an exponent. And if you wanted to prove to me, make a table. Show that if you plug in 1, 2, and 3, you're going to get 4, 8, and 12, and plus 1, plus 1, plus 4, plus 4. That's linear right there. We're adding to get to the next number. If this function is decreasing at a constant rate, decreasing means it's going down. That doesn't necessarily make it linear or exponential, but at a constant rate, meaning if you sketch a graph, we're going down at a constant rate, that is going to make us linear. It's decreasing at a constant rate. Number 5. This one, it's not linear. We can tell that it's not linear, but the exponential, sometimes it might confuse. So let's take a look at the table. If I have 3, I'm at 0. If I have 4, I'm at 1. If I have 7, it looks like I'm at 2. And if I have 12, it looks like I'm at 3. So this is plus 1, and this is plus 1. If we go up 1, 2, 3, because plus 1 worked, then we should be going up 3 here for it to be linear. So that's definitely not going to work. If you're multiplying, this doesn't work because you started at 0, and so 0 times 1 is not giving us 1. Even multiplying here, this is definitely not exponential. It's rising at a rate of 0, 1, 2, 3. That's not exponential. It should be getting larger much quicker. So I'm going with neither. This is neither. You're actually going to find out this is the shape of a square root function when you get into math too. Number 6, a person's height as a function of a person's age. Well, let's think about it. We're just guesstimating. Here you are at 10, 20, 30, 40. And let's say this is 1 foot, 2 foot, 3 foot. I probably should have made, we'll do my mom. She was really short. 5 foot. When she was a baby, she might have been 2 feet. How much are babies? 20 inches. We'll start with her. She was at like 1.5 feet. That's as a baby. And then she got bigger and bigger and bigger. At 10, she was probably about 4 feet. And then at about 15, she probably topped out at 5 feet. But at 20, she was still 5 feet. And at 30, she was still 5 feet. And at 40, she was still 5 feet. So, and do we all grow at the same rate? No. So this isn't linear, or exponential keeps going. This is going to be another example of neither. You could make a table too for me for age and height. You could give me some examples of age and height and show that there is no constant relationship. Number 7, it's not exactly in the form that we love of y equals mx plus b, but it certainly has one y and one x, so that is going to be linear. It's y equals mx plus b. You can make a table, put this in y equals mx plus b, make a table, draw a graph. Any of that could be your second type of explanation. Number 8, look at this table. This is going to be plus 2, plus 2, plus 2. 23 to 5 means we are going down. Let's try to subtract first. That's the first thing that we could do. And so 23 minus 5 is going to give me minus 18. Is 5 minus 18 negative 13? Well, it is. So minus 18, minus 18, minus 18, linear. It has a constant rate down. And you also could, your slope would be your change in your y, which is negative 18, over your change in your x, which is positive 2. So that slope is negative 9. You could draw a graph if you wanted to. You would be able to see that that is linear. Here, none of this is in order. 62, 74, 70, 67, 53, 58. Even if you put them in order, that's what I would want. Height, shoe size. If we are at 53 and 4, 58 and 7, 62 I think is next, 62 and 6, 67 and 11, 70 and 9, and then 74 and 13. See, we're going up, but our shoe size goes up and then back down and then back up and then back down. Neither. The number of cell phone users in Centerville as the function of years, if the number of users is increasing by percent, that should show us percent. That means we're multiplying each time, multiplying. If it's increasing by 75%, it will be 1.75, right, to the x. That's exponential. You can make a table. 11, that should be screaming at you, exponential. You can make a table. Make a table is proof. 12, time it takes you to get to work as the function of the speed at which you drive. Well, I don't know about you, but when I am driving, you go fast, and especially to work. You pick up some speed, and then you slow down, and then you stop, and you wait, and you get fast, and you stop. It could be linear at times, but normally we don't. We really don't go. Here's our time. Here's our speed. Sometimes we speed up really, really fast, and then we have to slam on the brakes and stop. And then you could go a little bit faster, and then you could stay constant, and then slam on the brakes and stop. So this is going to be a neither. Y equals 7x squared. We haven't really worked with anything in that. X squared, you could make me a table. You could make me a graph, but this is a neither. Oh, I have 3 more. 30 seconds. Each point on the graph is exactly 1/3. That means multiplying by 1/3. That's going to be exponential. Table or graph would work as proof. 15. Here we get x and y 1 is 7. I'm going to have to do a second video. Sorry.